Okay, now we're going to do some solving, and again, just remember, all the answers are on the unit circle. It's just a matter of figuring them out. So the cos theta equals negative root 2 over 2. Well, cos is the x value. So I just go around and find where is the cosine negative root 2 over 2, or where are the x coordinates negative root 2 over 2. And it's at 3 pi over 4 and 5 pi over 4. So those are the two solutions. And it really is just that easy, except for when it's tan. Tan is always the oddball. So when we're doing tan theta equals 1 over root 3, what you always have to remember is that this was probably something over 2. So this is 1 over 2 root 3 over 2, and the numerator is the y value, the denominator is the x value. So we're looking for points that have coordinates root 3 over 2, comma 1 over 2, but because it's divided, they can either be, because it's a positive, it's either two positives or two negatives. So there's two locations with coordinates root 3 over 2, 1 over 2, or it could have been negative root 3 over 2 and negative 1 over 2 because they both would have canceled out. So that means there's two possible solutions on this one, pi over 6 or 7 pi over 6. Okay, C, sine theta is negative a half. So I'm looking for where does a y value negative a half. So y is negative in quadrants 3 and 4. So at 7 pi over 6 and at 11 pi over 6, I see y values of negative a half. All right, sine theta equals negative 1. So again, we're looking for a y value of negative 1, which is down there at 3 pi over 2. So theta equals 3 pi over 2, which is kind of an oddball because there's only one solution. And it's the same sort of thing happens with cos theta equals negative 1. Only place cos theta is negative 1, which is an x value of negative 1, is at pi. So we only get one solution, theta equals pi.